This is a video on function notation and how to use it to evaluate functions using equations or graphs or tables. Up to this point in math, you've probably been using x and y as variables. No doubt there's been other letters, but x and y are extremely popular, and the x has been considered the input value and the y is the output. In function notation, the y on the left-hand side of each equation is replaced by this new expression f, open parentheses, x, close parentheses. In the second equation, it's been replaced with g of x, and in the third one, it's h of x. All of these x's inside these brackets are matching the variable that's used in the original equation. So this says that f of x is equal to 3x minus 7, g of x is equal to x squared minus 1, and h of x is equal to the sine of x. These equations mean exactly the same as the ones on the left. It's just one uses y and one uses function notation. One of the advantages of function notation is that it is a very compact way of expressing the relationship between the input value x and the output value f of x or y. So if this was written in the traditional y is equal to x squared minus 1 way of writing an equation, and I wanted to know what is y when x is equal to 3, I would have to ask, what is y when x is equal to 3? Using function notation, I can write f of 3. And this represents exactly the same thing with fewer words, fewer pen strokes, and less mess. So this says f of 3, this is a y value, and on the right-hand side, this x has been replaced with 3 on the left. I'm going to replace it with a 3 on the right. 3 squared minus 1 is 9 minus 1, which is equal to 8. So that is a very quick way of asking a question about the input or output values. I can also ask, what is x when y is equal to 0? So instead of having to write down what is x when y is equal to 0, I can write f of x is equal to 0. This time I need to replace the left-hand side with 0. So f of x this time is 0, and I can fill in x squared minus 1. And there are two numbers that make this equation true. X squared minus 1 equals 0. That can have the solution x is equal to positive 1 or x is equal to negative 1, which can be shortened to x is equal to positive or negative 1, plus or minus 1. Solving these equations for x is generally a lot more work, but solving them or evaluating them when you're given an x value is what they're set up for. We can also evaluate functions from a table. In this table, we're given a list of x values and a list of y values, or g of x values. And when I'm looking for the y value when x is one of the numbers on this list, I can simply write, so what is y when x is equal to 0? I can write g of 0. So this says, what is y when x is equal to 0? So that's this row here. When x is equal to 0, y is equal to 6. This table, it is not as difficult to figure out y values. So if I wanted to know what is x when y is equal to 10, this time I'm given a y value of 10 and I'm asked for an x value. Y is 10 in this row here, so this has the solution x is equal to 1. Another way that a function can be displayed is through a graph, and this is the graph of the function y is equal to h of x. So for every x value on this graph, there is a corresponding y value. And I can use function notation to ask the question, what is y when x is equal to 3? I'm sorry, what is y when x is equal to 0? When x is equal to 0 in the function h, we will get a y value. So h of 0 is the y value when we put in x equals 0. So going along the x equals 0 line, which is the y-axis, we follow it up or down until we hit the graph. And the graph is right there. So when x is equal to 0, y is equal to 3, h of 0 is equal to 3 is how to say that in function notation. We can also ask what is x when y is equal to 1? For this, there's two solutions because the line y is equal to 1 passes through the graph in two places. One of those places is not very easy to see, but it is at 2/3, 2 over 3. That's one of the solutions to h of x is equal to 1. The other solution is at x is equal to 4. So on this graph is the point 0, 3. That's this point here. 2/3, 1. That's this point here, and 4, 1. And in function notation, this says h of 0 is equal to 3. If h of x is equal to 1, then x is equal to 2 over 3 or 4. And that's how you work with a graph and function notation. So we've been replacing the input variables, the x's, with a number and simplifying or finding what y value goes along with that. That is called evaluating a function. When we have equations of functions and we put the input as a number, the output will be a number. But we can also put in an expression and the output will often be another expression. It might not be a simple single number. So a function in very general terms is a set of instructions of what to do to an input to produce an output. So we're going to do a little bit of unusual inputs and see where that gets us with function notation. We evaluated f of 3 by replacing the 3. The x was replaced by 3 on this side. The x is going to be replaced by 3 on this side as well. So it was 3 squared minus 1, which was equal to 8. I can put any number into this x, and I will get a number out for f of x. This also says that somewhere on the graph of this function, there is a point where x is equal to 3 and y is equal to 8. So the point 3, 8 is on the graph of this f of x. But I'm not limited to numbers. I can also replace this with letters. So I can ask for f of a. So the x has been replaced by a on the left-hand side. I'm going to replace it with a on the right-hand side and simplify as much as possible. Not much I can do. A squared is a squared. And this makes a lot of sense. When x is equal to a, x squared minus 1 is equal to a squared minus 1. The x just changed its name. So on this graph of f of x is equal to x squared minus 1, there's also some point a, a squared minus 1. Not very interesting, but that's what this point represents. This is the x value, this is the y value. For students who are about to start studying calculus, this is something that you have to do quite a bit of. F of x plus h. This is usually a little bit more work. So this time, the x on the left-hand side was replaced with x plus h, so I'm going to have to do the same thing with the right-hand side. So instead of x squared, I want the entire expression x plus h. I want to square it and take away 1. This needs to be squared using distribution or foiling. So if I was to write this out expanded, it would be x squared plus x times h plus another x times h, so plus 2xh plus h squared minus 1. So when we replace the input with an expression, we generally get out another expression, and not always a very pretty looking one. As a review, function notation has some good points and some bad points. One of its good points is that it is compact. It contains a lot of information without having to write a lot or having to say a lot. This is also one of its bad points because any compact notation is usually difficult to get started using, but it does get much easier. Another good point of function notation is that it states clearly what the input variable is going to be. If I tell you that f of x is equal to something, you know that the input variable is going to be x. Or s of t, you know that the input variable is going to be t. Another really important thing that function notation does is it allows us to express composite functions, and it's necessary to express composite functions. It can also be used when there's more than one input variable in multivariable calculus. The other bad point about function notation is that the parentheses are often misread and confused with multiplication. So when you see f and then some parentheses with an x inside, or a number, it does not mean multiplication. It's one of the very rare times when parentheses do not mean multiplication. So to review, the three most common ways of expressing the relationship between an input x and an output y is with an equation, a table of values, or a graph. And we can evaluate each of these functions at a point, as long as the point is visible from the way that the data is presented. So if I want to know f of -1, I've replaced x with -1 on this side of the equation. I need to replace it with -1 on the other side. So -1 squared minus 1 is 1 minus 1, which is equal to 0. F of -1 for this function f is equal to 0. G of -1, I don't have to do any calculating, but I do have to find where on the table x is equal to -1. That's this row here. When x is equal to -1, y is equal to 2. So g of -1 is equal to 2. Finally, in this graph of y is equal to h of x, h of -1 is how high or low the graph is when x is equal to -1. So if I follow along this line, x is equal to -1, I will hit the graph at +6. F of -1 was 0, g of -1 was 2, h of -1 was equal to 6. This is how you evaluate using function notation.